Good morning, everybody. Welcome to our science class. In the previous class, we started chapter 4 sorting materials into groups. Here, page number 35 and 36 finish. And classification of materials, classification of things we started. Okay, all of you take your textbook, page number 37. We are going to start now. Basis of classification. Heading Basis of classification. Materials or substance can be classified on the basis of their properties. The properties of a material determine how it is used. On the basis of property, materials are classified. That's given here. Okay. Some simple properties on the basis of which material can be classified are as follows. How materials are classified on the basis of properties are given here. Okay, first one, luster. L-U-S-T-E-R-E. Luster. Luster is the shining of a material. Material shining, no, that is what a luster. Luster is the shining of a materials. You might have noticed that some objects shine but some don't shine. We know that some objects, some materials maybe will shine and some materials do not shine. For example, all materials in pure state are shiny and said to possess luster, while some materials like paper, wood, etc. do not have luster. Okay, some materials, that pure materials will shine and some materials do not shine. Okay, luster here given there. Okay, so silver cutlery, utensils and all, that it will shiny. And cycle handle, that also when we buy new one, no, it will be it will luster. Next one, gold jewelries, it will be very shiny. Next one, the materials which have a special shine on them are said to be lustrous, and those which lack luster are called dull. Okay, materials which have shiny are said to be lustrous. Lustrous, lustrous. What do you mean by lustrous? The materials which have a special shine on them are said to be lustrous, and those which lack luster are called dull. Materials which have less luster, lack luster, are called dull. The main points, sorry, I will go to the right side. Okay, the metals with a clean surface have luster. However, they lose their luster when exposed to air and moisture. The materials which are clean surface are called luster. If it is in good finishing, then it will be luster. And however, they lose their luster when exposed to air and moisture. Especially this metal. So about metals here saying, okay, the metals, if it is in good finishing, it will be luster, it will glazing will be there. And if we keep just outside, however, they lose their luster when exposed to air and moisture. When we expose to air and moisture, then luster will go. Okay, it will become less, an extra bit. Graphite and iodine are two non-metal which also have shining. Graphite and iodine both are not metals but shining. Okay, so it's also luster. Next one, physical state. Physical state. Materials can be classified on the basis of their state. All substances are made up of matter. All substances are made up of matter. Anything that has mass and occupies space is called matter. What is a matter? Matter means anything that has mass and occupies space is called matter. That means any object it has mass. That means uh, weight. Okay, mass means weight. उसमें वजन होगा. And also it occupies space is called matter. It occupies space also. Hmm? Such materials are called what? Matter. Matter can be classified into three states: solid, liquid, and gas. In the class 4 and class 5 also I think you learned this. So matter can be classified into three states: solid, liquid, and gas. See, small one chart is given there. Okay, the main points of difference between solid, liquid, and gas are as follows. First one solid, next liquid, next gas. Solid, definite shape and volume. Solid has a definite shape and volume. In front of you, you can see there your book is there, table is there, mobile will be there, pencil, pen. It all have a definite shape. Yes, no? And see, liquids. Liquids, definite volume but no definite shape. Definite volume will be there, but a definite shape will not be there in a liquid. They take the shape of a container in which they are stored. Wherever we put no, and that uh, area's shape it will adapt. Okay. If we pour on the floor, no, it will spread everywhere. If we pour on a bucket, that shape will come. If we pour on a glass, that shape will come. Like that, no, it will change its shape. Next, gas. No definite shape and no volume. And volume. No definite shape, no definite volume. Volume also increase and decrease, and shape also always will change in gas. Next one, cannot be compressed. Solid cannot be compressed. We can't compress it. We cannot reduce it. Can be compressed to a small extent. Little bit we can compress. This is a liquid. And gas, highly compressed. Gas we can highly compress. Example is our cooking gas, highly compressed gas. Okay, that one. When we it become outside, no, it will expand many times. Next one, particles are closely packed. Okay, in solid, particles are closely packed. But in liquids, particles are not as closely packed as in solid. In liquids, particles are closely packed, but not like solid. In solid material, particles are closely packed. That's why it will be hard. Okay, and in liquid, particles are not as closely packed as in solid. Next, in gas, particles are loosely packed. Okay, in gas, particles are packed very loosely. Okay, that's why it will change its shape very quickly. Okay, here example also given there, you can see there. Okay, next one, roughness. Next one, roughness. Materials can be rough or smooth. When we touch, no, we will feel it. Okay, materials can be rough or smooth. Roughness or smoothness of a materials can be felt by touching. uh, how we can feel it? We can felt by touching only. For example, sandpaper, wood, rocks, uh, bark of a tree are rough materials, while a flower petal and a glass sheet are smooth. Examples also given there. Okay, means wood. What we can say, sandpaper, wood, rock, and bark of a tree. It's a chamada. This all will be rough, but a petal of a flower and a glass surface, this all will be very smooth. That also one kind of classification. Next one, hardness. Hardness is another property of material on the basis of which materials are uh, classified. This is also one another kind of classification. Okay, the ability of a material being scratched is known as its hardness. Remember, hardness is a comparative property. Hardness is a comparative property. It is hard or not, we can't say directly. Uh, when we compare with other objects, then only we can say it's hard or not. When the surface of two different materials are rubbed against each other, the surface which scratch is said to be hard, and conversely, the surface which gets scratched is said to be soft, as compared to the scratching surface. You can see there one, we can say, hard substance. One nail is given there, one what we can say, crayon is given there. Okay, if you scratch both, no, then what will happen there? The crayons will uh, be scratched. That is soft, that's why. But a nail will not be scratched. It is very hard, that's why it will remain like that. Say, next one, solubility. Okay, next one, solubility. Many substances are soluble in water, whereas others are not. Many substances, many things are soluble in water, but many are not. Based on their solubility, materials can be soluble, insoluble, miscible, or immiscible. Like that, no, we can be divide. The solid materials that dissolve in water are said to be soluble materials. Materials which are dissolved in water, that it will melt in water. Example, sugar, salt, and all. No, when we, if we mix this one in water, it will mix with water, dissolve in water. Such materials are called water soluble materials, and those which do not dissolve in water are called insoluble materials. For example, sand or other metals and all. For example, common salt is soluble in water, sand is insoluble in water. Next one, liquids that mix with each other are called miscible liquids. Liquids also we can mix, but some liquids will can't mix with each other. Okay, that immiscible. Okay. Okay, liquids that mix with each other are called miscible liquids. For example, water and milk are miscible. Water and milk are miscible, and liquids that do not mix with each other are called immiscible liquids. For example, water and oil are immiscible liquids. You can check at home. If you mix with water and cooking oil or any kerosene oil, it is immiscible. Okay, it will not mix. Some gases also dissolve in water. Gases like oxygen, carbon dioxide dissolve in water. Oxygen and carbon dioxide will mix with water. Okay, dissolve with water. Oxygen dissolved in water is essential for aquatic life. Aquatic life means many animals are living in water. They are getting oxygen from water only. So, what is oxygen is mixing with water is very important. Otherwise, aquatic life will not be possible. Next one, soft drinks, cold drinks contains dissolved carbon dioxide. When we buy Pepsi, Coca-Cola, and all, no, their carbon dioxide is compressed there. Okay, mixed in water. So that's why air is coming. No, when we open it. That means carbon dioxide and oxygen both are dissolved in water. Some gases like nitrogen, methane, etc. do not dissolve in water. Nitrogen and methane do not dissolve in water. Okay, here one experiment is given there. Okay, all of you look it. Okay, find out whether the given substance is soluble or miscible or insoluble or immiscible in water. Materials required: sugar, chalk powder, washing soda, sand, kerosene, and lemon juice, and test tubes, water. This much materials necessary. Some things you can also check at home. Okay. Methods: take 6 test tube, fill each of them half with the water, place them on a test tube stand, and add a pinch of sugar, chalk powder, washing soda, and sand separately in a 4 test tube. To the fifth test tube, add 2-3 ml of kerosene, and the sixth test tube, add 2-3 ml of lemon juice. Shake each test tube well and put them back onto the test tube stand, and observe after 1-2 minutes. What do you observe? Hmm? And we need six test tubes here, and all test tube half of water you have to take. In one test tube you have add sand, and next one sugar, and third one washing soda, fourth one chalk powder, fifth one kerosene, last one lemon juice. This much things you have to add with that water and mix it, and keep few minutes. After that you observe what we can find it there. Okay, see, first one, particles of sugar and washing soda have disappeared. And sugar and washing soda disappear, that means completely dissolve in water. Thus sugar and washing soda are soluble in water. That we can find sugar and washing soda is soluble in water. Next one, chalk powder and sand particles are left in as such. Yeah? And the sand and chalk powder both left in water. Thus, chalk powder and sand are insoluble in water. Here we can see sand and chalk powder are insoluble in water. Next one, kerosene forms a separate layer on the surface of water. This kerosene is insoluble in water. Kerosene will make a separate layer on the top of the water. That means kerosene also insoluble. Okay. And last one, lime juice and water form a single layer. Thus, lemon juice is soluble in water. Lemon juice, if we mix with water, it will it is soluble in water. Okay, it will make one. Okay, it will not create another layer. A conclusion, on the basis of solubility in water, sand and chalk powder are insoluble in water, sugar and washing soda are soluble in water, kerosene is immiscible in water, lemon juice is miscible in with water. Okay, that much you all of you understood. This some experiments you can also check at home. Okay, and sand will be there at home, sugar will be there, washing soda will be there, chalk powder if it's not there then leave it. Kerosene will be there, lemon juice also will be there. Okay, if test tubes are not there, in a glass you can check it. Okay. Okay, today this much enough, and all of you read the teaching portion very carefully 2-3 times. Okay, then bye. Have a nice day.